Hey everyone, welcome to Edu-Malanga, where we create math video tutorials for the Matric syllabus of South Africa. We're currently working through the third unit of the year, and on this unit we look at exponential and logarithmic functions. We're currently working through examples on logarithms and the laws of logarithms, and today we are going to do two examples. If you're not familiar with logs, there's a link in the top right corner to a video that we did on this channel where we introduced logs and we also looked at the laws of logs, so follow that and you'll be able to do the examples with us today. If you're comfortable and ready to do some examples, let's get going. Let's start with example 1. In example 1, we're asked to solve for x, and then we're given 4 expressions in which we must solve for x. Let's start with A. In question A, we're told that log base 5 of x is equal to 4. Let me rewrite it on this page. A, we're told that log base 5 of x is equal to 4. To solve this question, let's recall the relationship between exponential functions and logarithmic functions. I'll start by writing an exponential function. Our exponential functions look like this. We have y is equal to a to the power of x. The logarithmic function that would correspond to this exponential function would be log base a. So our base would stay the same between the exponential function and the log function of y. And so now with log, the final answer is the input. And what do we get? We get x, which is the power in this expression. The exponential function and the log function have the same base. Your base remains a, and the power of the expression in your exponential function is the final answer in your log function. I hope you understand this relationship. So let's turn this expression into an exponential function in order to solve for x. Remember, the base stays the same and we had log base 5. So we're going to have then 5, and the power, what do we power it to? This is 4. So we have 5 to the power of 4 should equal to x. And if you put this in your calculator, you'll find that x is equal to 625. The next question for us to answer is B, and in B we're told that log base x of 256 is equal to 8. Again, what we're going to do is use the relationship between exponential and logarithmic functions to solve this. So let me rewrite this expression. For B, we have that log base x of 256 should equal to 8. Remember, in the exponential function and in the log function, the base remains the same. So our base will be x, and the power is the final answer over here. So x to the power of 8 should equal to 256. To solve for x, we're going to take the 8th root of 256. That will be x is equal to the 8th root of 256. You can enter this into your calculator, and the answer that you will get is equal to 2. But there is another answer as well, and let's not forget it. If you say negative 2 to the power of 8, you will also get 256, and so the actual answer is plus or minus 2. When you're taking roots of numbers, it's important to always remember to check whether the negative answer would also be applicable. This is especially true if the root that you are taking is an even number. So let's move on to C. In C, we're given that 6 to the power of x is 1296. I'll rewrite it again. C, we're told that 6 to the power of x is equal to 1296. To solve for x, I'm going to turn this exponential function into a log function now. So I'm going to have log base 6. Remember, the base stays the same, of 1296 is equal to x. And if I put this into my calculator, I will find that x is equal to 4. The last question we solve in example 1 is D, and the question in D is that log x is equal to 4. Let me rewrite it again. D, log x is equal to 4. Remember what we said about log base 10. When your log has a base of 10, you don't write down the base, you simply write log. And so what we know from this is our base is actually 10. So we'll turn this log function into an exponential function, and we're going to have the base be 10 to the power of 4, and that's going to equal to x. Put this into your calculator and you'll find that x is equal to 10,000. And we're done answering example 1. Let's move on now to example 2. In example 2, we're asked to use logs to solve for x again, and we're given 3 expressions to solve this time. Let's get started with A. In A, we're told that log base 4 of x squared plus 6x should equal to 2. I'll rewrite this expression on the next page and we can start solving it. And so it will be log base 4 of x squared plus 6x should equal to 2. Let me use substitution to simplify this expression. I'll say let k equal to x squared plus 6x, and so the expression will then be log base 4 of k should equal to 2. If I turn this into an exponential function, I'm going to be able to find out what k is. The exponential function for this expression is going to have the same base, so it will be 4 to the power of 2 should equal to k. 4 squared is equal to 16, and so k is equal to 16. Let's substitute back into this expression. What we will have is that 16 is equal to x squared plus 6x. Remember, we're trying to solve for x, so we're going to take the 16 to this side of the equation, and what we will have is we're going to have x squared plus 6x minus the 16, because when it moves from this side to that side, it changes signs, and this whole expression will be equal to 0. Let's use factorization now to solve for the two solutions of x. We're looking for factors of negative 16 that when you add together give you positive 6. If you say 4 times negative 4, when you add these you get 0, so this is not possible. The next two factors of negative 16 can be 2 times 8. If the 2 is negative, 8 plus negative 2 gives you 6, and so these will be the two factors. The expression will then be x minus 2, close brackets, and x plus 8, and this is all equal to 0. In order for this expression to equal 0, x must equal to 2 or x must equal to negative 8. So this is the solution for question A. Let's move on now and answer question B. In B, we're told that 5 times 4 to the power of x minus 3 should equal to 84. Let me rewrite the expression. 5 times 4 to the power of x minus 3 should equal to 84. I'm going to apply log on both sides of this expression. What I will get is log 5 times 4 to the power of x minus 3 should equal to log 84. If you remember the laws of logarithms, when you have log of a times b, you can convert that into log of a plus log of b. So I'm going to do that for these two expressions. What it will then become is log 5 plus log 4 to the power of x minus 3 should equal to log 84. The next step I'm going to take is to group like terms. So I'm going to move log 5 to this side of the equation, and then I'm going to move this power to the front of this log and multiply by it. So let's continue. We're then going to have x minus 3, and this is going to multiply our log of 4, and it'll be equal to log 84 minus log 5. Remember, we're solving for x, and so we want to isolate the x. To do this, we're going to divide by log 4 on everything. Divide by log 4, divide by log 4, and divide by log 4 here as well. The log 4s will cancel out on this side, and then we're going to be left with x minus 3 is equal to, use your calculator to simplify each of these expressions. If we work to 2 decimal points, we're going to have log 84 divided by log 4 is equal to 3.20 minus log 5 divided by log 4. That's equal to 1.16. If we simplify this side further, we get that x minus 3 is equal to 2.04. Remember, we're solving for x, so we're going to move the negative 3 to this side of the expression. We then get x should equal to 2.04 plus 3, and so x is equal to 5.04. And this is the solution for question B. Let's do the last example for today. The last example for today is C, and that's 4 to the power of x minus 2 is equal to 4096. I'll again rewrite the expression. C, 4 to the power of x minus 2 is equal to 4096. I'm going to apply a log on both sides of this equation to solve, and it'll become log of 4 to the power of x minus 2 should equal to log of 4096. If we recall the log laws, this power can be moved to the front of the expression and we multiply by it. So this will become x minus 2 times log 4 should equal to log of 4096. The next step is to isolate the x, and so we'll divide by log 4 on both sides. Divide by log 4 over here and divide by log 4 over here as well. The log 4s will cancel out on this side, and so we're left with x minus 2 should equal to log of 4096 divided by log of 4. If we put this into our calculator, we find that x minus 2 is equal to 6. And so when we move the negative 2 to this side, we get that x is equal to 8. And this is the end of the example video. I hope you understood everything that I did and that you were able to follow. If you have any questions, please leave them for me in the comments section, and I'll try my best to answer them. Join us in the next video where we're going to start looking at logarithmic functions.